feels simple. You switch it on, the room brightens, and life goes on. We grow up believing light travels in straight lines, obedient, predictable, almost boring. But what if that belief is wrong? What if light, this most familiar thing in our lives, quietly changes direction every single day right in front of us? Not because of magic, not because of illusion, but because of a fundamental rule of nature that most people never truly notice. In this video, we're not talking about expensive labs or advanced technology. We're talking about a glass of water, a beam of light, and a simple experiment that exposes one of the deepest truths about how the universe behaves. By the end, you won't just see light differently, you'll understand why reality itself bends when conditions change. This is not a trick. This is not theory. This is real physics happening in real life, and once you notice it, you can't unsee it. Take a transparent glass, fill it with water. Place a pencil, spoon, or straw inside it. Now step back and look carefully. The object appears bent, broken, almost snapped in half at the water's surface. Your brain knows the object is straight, but your eyes insist otherwise. This moment is where real science begins. No equations, no assumptions, just observation. Light enters the glass, passes through air, then water, then air again before reaching your eyes. Somewhere along that journey, its path changes. The experiment doesn't require belief. It demands explanation. Why does the object appear displaced? Why does the bend always occur at the boundary between air and water? This tiny setup reveals a massive idea. Light does not travel the same way in every environment. And that single truth reshapes everything we know about vision, optics, and reality itself. Subir reveals a massive idea. Light does not travel the same way in every environment. And that single truth reshapes everything we know about vision, optics, and reality itself. Light is not a solid thing. It's not a particle marching forward like a bullet. It's energy moving through space, responding to the medium it travels through. When light moves through air, it travels fast and straight, but when it enters water, something changes. Water is denser, its atoms are closer together, and when light encounters this new environment, it slows down. That slowdown forces the light to change direction, not randomly, but precisely. This bending is not a mistake of vision. It is a natural consequence of how light interacts with matter. The moment light crosses the boundary between air and water, its speed changes and direction must change with it. This is not optional. This is physics enforcing its rules. Your brain assumes light always travels in straight lines. It evolved that way because in everyday air, light mostly does. So when light bends, your brain doesn't update the model. It misinterprets the result. The brain traces the incoming light backward in a straight line, assuming no bending occurred. That false assumption creates the illusion of a broken object. The illusion isn't in the water, it's in your perception. This is why optical illusions are so powerful. They exploit the brain's shortcuts. The experiment reveals not just how light behaves, but how human understanding can fail when reality changes conditions. Nature follows rules. The brain follows habits. The exact point where light bends is the surface, the boundary. Air to water, water to glass, glass to air again. Each boundary forces light to adapt. Think of a marching crowd suddenly stepping onto mud. Their speed drops, their formation shifts, their direction changes. Light behaves the same way. The angle at which light enters determines how sharply it bends. Shallow angles bend more, straight-on angles barely bend at all. This is why the pencil looks more distorted from the side than from directly above. This isn't randomness, it's consistency. And consistency is how science proves truth. Every camera lens, every pair of glasses, every microscope relies on this exact behavior of light. Engineers don't fight refraction, they control it. By shaping glass precisely, they force light to bend in useful ways. Focus, zoom, magnify, correct vision. All of it comes from understanding how light changes direction when its environment changes. The simple glass of water experiment is the foundation of modern optics. From telescopes exploring distant galaxies to medical instruments saving lives, the same principle applies. Light bends. And when you understand how, you can shape reality. Mirages on hot roads, rainbows in the sky, swimming pools that look shallower than they are, the means by which light changes direction explains all of them. Even the sky's color depends on how light interacts with air. These aren't special cases, they're everyday consequences of the same rule. Once you understand this experiment, the world becomes readable. Every reflection, every distortion, every shimmer tells a story about light's journey. Physics stops being abstract and starts being visible. This experiment matters because it teaches something deeper than light. It teaches how to think. You observe, you question, you test, you explain, no authority required, no advanced math needed, just curiosity and honesty. This is how science actually works. Not memorization, not formulas first, but understanding born from real observation. The experiment proves that complex truths often hide inside simple setups. You don't need a laboratory to uncover reality. You need attention. At its core, this experiment reveals a universal truth. Nature always chooses the most efficient path under given conditions. Light bends not because it wants to, but because it must. The environment dictates behavior. Change the medium, and behavior changes with it. This principle appears everywhere, in sound, heat, electricity, even human systems. Understanding light's behavior becomes a metaphor for understanding change itself. Conditions matter, context matters, direction is not fixed. So the next time you see a straw bending in a glass, don't dismiss it. That bend is light revealing its rules. A quiet demonstration that reality is more flexible than it appears. This simple experiment doesn't just explain how light changes direction. It explains why understanding begins with observation, not assumption. Light didn't change, you did. Because once you understand this, you stop seeing the world as flat and obvious. You start seeing it as layered, responsive, and governed by invisible laws that reward those who look closely. And that, right there, is the real power of physics.